Hi everyone, this is just a overview and I guess a sort of electronic key to Quiz 1. There are two different versions of this. I'm going to work through it and see how I would have went about solving it, and hopefully this will help you guys as you prepare for future quizzes, exams, stuff like that. So one thing I wanted to mention, I had you all do this reflection, and the reflection question I asked was about how you felt about this quiz. I've been looking through it. It looks like most of you feel like you did worse than expected. A couple maybe said better than expected, but a lot of you, said that in order to do better in the future, you might try to go to tutoring, and I definitely would suggest that. Again, on the Blackboard site, if you go there, I've got the tutoring schedule posted up here. If you look down here, this thing says tutoring schedule. It looks something like this, right? So there's chemistry department tutoring, and there's special chemistry tutoring in the library, so do check that out. But in regards to the quiz, there are actually two different versions, actually three different versions, but I'm going to show you guys two of them, because most of you got one of these two. The last one was for the people who did theirs a little bit later. So the first one was a ranking problem, and this required some unit conversions using the metric system and prefixes. And so the key to all of these sort of metric system problems are to get things in the standard unit. So what I mean by that, if you had this question, what you want to do is compare them all in terms of liters, the base unit. And so so what I would do is I'd start with this top one. I'd say, okay, what is 1 kiloliter in liters? In order to use it, you need to know your prefixes. And again, I gave you guys a list earlier of ones I expected you to memorize. It's on slides. I believe it's from the first or second day of class. Those are also in your textbook. They're highlighted in green in your textbook. Those are the ones I expect you to know. And so you set it up, so you put the modifier with the, right, you want your final term to be in liters. And so you're going to 10 to the 3 liters per 1 kiloliter. Okay, so it's basically saying 1,000 liters per kiloliter. So if you use that conversion, you get 1 times 10 to the 3 liters. Okay, that's the first one. Second one, we'll change colors for these, is in microliters, and this one I know a number of you didn't remember. So this is a new one. Some of you may not have seen this in school, and so we need a conversion factor 4,000 microliters. And the conversion factor you need to know is that for a microliter, it's 10 to the minus 6 liters, so 1 microliter. And your final answer ends up being 4.0 times 10 to the minus 3 liters. Okay. This next one is straight. It's just straight up. Already in your base units, it's 5.5 times 10 to the minus 4 liters. And your final one is in milliliters. We need to convert that into liters. So we go here. And 3.1 milliliters times this conversion. So you have 1.0 times 10 to the minus 3 liters per 1 milliliter. And then your answer is 3.1 times 10 to the minus 3 liters. Okay, so now we need to rank these from lowest to highest, and I said 4 is going to be the highest. So let's use orange for that. Okay. All right, so the largest one here, right, all these three are all less than 1. This one is 1,000, so this is going to be your largest one. So this is going to be 4. Right, and so I'm going to write that as 4 over here. The second largest, if you look at this, right, these are 10 to the minus 3 here. This is 10 to the minus 4. So this one's actually going to be your smallest, okay? So since this one's your smallest, this is going to be 1. So that's your smallest. And then between these two, you see this one, these are both on the same scientific notation scale. And so 4 is slightly larger than 3.1. So that means this one's going to be your second largest. So I'm going to call that one 3. This one's going to be your smallest, your second smallest. I'm going to call that one 2. So we go with 3, 2. Okay, so that's the general process. All right, so I'm going to do another one of these. It's going to be basically the exact same process. So we'll start at the top here, and the top one here is in milligrams. You want to get that into grams. Remember, you want to go into the base unit. So 35.2 milligrams. The conversion factor, just like before, for milli is 1.0 times 10 to the minus 3 grams, 1 milligram. And so this ends up being 3.52 times 10 to the minus 2 grams. Okay. Keep going. So this one's direct here. So this one is, right. This one's straight up just 1.02 times 10 to the minus 2 grams. Sorry, that should be 0.02. All right. The next one here is in centigrams, and so you convert this one, right? So centigrams, if you remember, is 10 to the minus 2. O times 10 to the minus 2 grams per 1 centigram, and so this ends up being 2.0 times 10 to the minus 1 gram. And finally, you have micrograms. So our micrograms are, again, it's 10 to the minus 6, so you get 1.0 times 10 to the minus 6 grams per 1 microgram. So you go through your calculation, and you end up with 1.0 times 10 to the minus 3 grams. Okay, so now we rank them just like we did before. You have to understand scientific notation to do that, and so the largest one, let's start with so these are all less than 1, okay? And the largest one is going to have the smallest negative superscript here, and so that's this. Right? These are all minus 2, this one's minus 3. So this one's going to be your largest. Right? This one's going to be your smallest, right? Because this one has the most negative superscript. It's going to be 1, all right? So you can fill those in. So this is 4, 1. All right, and the next two here are both in the same superscript. You see this one's 3.5 and that one's 1.02. So this one is going to be your second largest, and the final one is going to be your second smallest. Okay. So I think what a lot of people did on this particular problem is that either they forgot what these prefixes meant, what they stood for, or what they did was they ignored the number in front of them, and they just said, okay, I know that grams are bigger than centigrams, so this one must be larger. But you have to pay attention to that number that's in front of it. Okay. And so you need to get them all into the same base unit to compare, and it's the same thing for this first one. Okay. So the second question, people did in general better on this one. What you need to look at here was to see that the right, what I have here is an isotope. Right, and this isotope, that number up there is telling you this is your mass number. So remember, the mass number, this is sometimes called A. Which equals your protons plus neutrons. Another thing you need to remember, so that mass number here, you can just fill right in. All right. The other thing you want to do is to look for so the second thing you want to know is that the atomic number is Z. That's the number of protons. Okay, so in order to do that, most of you had to look at the periodic table, and I'm going to pull one up here in a sec. Okay, so you need to look at your periodic table here, and you saw that bromine here, this number in the upper right hand corner here, that's your atomic number Z, so that tells you how many protons there are in your, where are we going here? Oops, this is what I wanted. So Okay, so so we looked at our periodic table and we saw that our atomic number for bromine was 35, right? And so that means that we have 35 protons. And so in order to figure out how many neutrons you have, you simply plug in for this equation here. You say that A equals 81, which is going to equal our protons plus our neutrons. And so if you subtract this out, you end up with a number of neutrons of 46. Okay. Alright, so you basically do the same process but in reverse for the second one. So what I would do is I would look for the number of protons because that's going to tell you what element. If you look at our periodic table, you look for the one with 12 protons. Turns out that that is also going to be your atomic number. And based on the periodic table, this is going to be magnesium. Okay. And so our number of neutrons is going to be our mass number minus our number of protons. So that's going to tell us that our number of neutrons is 13. Okay, so we got 25. And so this, I marked everybody correct for this. The full answer would have put a 25 up there, but as I said, I didn't mark anybody wrong for that. Okay, so you just do the same process here. In this case now we're looking at carbon. Okay, so carbon has, when you look at the periodic table, our mass number is right here, so it's 13. The atomic number is right off the table, is 6. Periodic table, our number of protons is the same thing as our atomic number, so it's also 6. And so our neutrons is our mass number minus the number of protons, right? And so that tells you it's 7. And so this one, you'll see, is sort of the reverse of what we did before. So now we've got the number of protons is 35, so that means our atomic number is also 35, and our mass number is just going to be a number of protons plus a number of neutrons. So this is 81, okay? And then, this might look familiar, this ends up being bromine, 81. Okay, and again, just like the magnesium, I did mark people off for doing that one incorrect. Okay. Alright, so that's it. As I said, the class average on this was about 50%, a little bit less. You do need to know this stuff because it's going to continue to come up throughout this course. So if you're having a hard time, again, either talk to me, go to one of those tutoring hours that I showed you, maybe work on some extra practice problems in the book. Conversions are going to be key, metric systems is going to be key, understanding the properties of the atom are also going to be key. Okay, see you in class tomorrow.